Hello everyone, today I'm going to explain the carbon capture and storage as a method to reduce emissions from the atmosphere, emission of carbon dioxide, of course. What do we mean by that? What is carbon capture and storage? It's a technology to capture carbon dioxide from processes. Maybe you can capture up to 90% of the emission from industrial processes like cement or power plant or oil refinery. The captured carbon dioxide can be used for enhancing oil recovery, or it can be stored underground. Underground means that the captured carbon dioxide from a power plant, for example, can be transported to areas where we can store them, and then we can inject this carbon dioxide into deep wells, maybe actually reaching something like over 5,000 feet. In this case, this deep area, just a storage injection zone here. So basically it can be staying there for some time, for longer time of storage, or it can actually, as I mentioned, can enhance oil recovery. What does it do? The carbon dioxide capture can reduce the carbon dioxide concentration in the atmosphere, and so that it can reduce the global warming resulting from carbon dioxide in the atmosphere. Of course, this is although this is beneficial. What I mean here is reducing carbon dioxide is beneficial for many benefits. It has many benefits, like what we discussed before. But of course, there are some limitations. For example, this technology, the carbon capture and storage, can have a high capital cost and high energy cost, maybe ranging from $40 to $120 per ton. This is expensive depending on the source of carbon dioxide. Even sometimes, actually, this carbon capturing can be used for capturing carbon dioxide from fermentation process. This is basically, as you know, ethanol fermentation can produce carbon dioxide. This carbon dioxide can be recovered, and in this case, the cost will be lower than $40 because basically per ton, $40 per ton, because the carbon dioxide in this case has higher concentration, and of course the concentration in the stream is one of the factors affecting the cost of capturing. The second actually challenge is decreasing the industrial process efficiencies. Of course, is the more actually you add the more unit operation you add to the process, it can actually also decrease the efficiency of the process, and of course it decrease the revenue from this kind of industrial process. For example, if you have a power plant, you add more unit for capturing the carbon dioxide, so you have to have more actually cost, and this will be reflected on the revenue from this process. Of course, we need to have to use more water use. Of course, this is another challenge. Of course, another challenge is the transportation of the captured carbon dioxide. If we capture this carbon dioxide, it can be injected. Of course, it's really close to the injection injection wells. It can be actually easy to inject, but however, it needs to be transported. It can be either using tanks or using the piping. Of course, there are some lack of infrastructure. There are actually potential actually to increase this kind of infrastructure. There are not many applications in the US or in other places in the world. So basically, there are a potential to increase this number of systems. Of course, the safety also of stored carbon dioxide may be an issue or a challenge for these processes. Okay, how this carbon capture works? If you have actually a flue gas with carbon dioxide here produced from a boiler, this boiler producing, for example, steam for turbine to produce electricity. So one of the products is carbon dioxide. The carbon dioxide produced from this boiler can be captured through this process here. This process, this is the capturing process. It composed of solvent absorbing column or absorbing system, and then recovery system. After capturing the carbon dioxide, we have to recover back the chemical that is, or the solvent that is used for capturing carbon dioxide. So here, the carbon dioxide produced from the boiler is cooled down and then entering the absorption tower or absorption column here, and then where actually this in this column or in this tower a solvent is used with is mainly monoethanol amine. This is the most common solvent, and this solvent monoethanol amine is absorbing carbon dioxide, and then it can go again here to the next step, which is recovery of the carbon dioxide, of course, and recovery the solvent. And here, this is basically is done through adding heat. And what happened here, this is through this system, the carbon dioxide, the pure or the carbon dioxide released from this kind of recovery can be used, can compressed or transported to where it's used, and the recovered chemical, which is monoethanol amine, can be going back to the solvent absorbing or absorption tower, and then of course there are some kind of carbon dioxide that may actually also here carbon dioxide here can go again. Some, of course, as we mentioned, maybe the efficiency is 90%. So basically, some of the carbon dioxide may also go here through the flue gas and then ending up to the atmosphere. So of course, this basically here is flue gas without carbon dioxide, but sometimes also depending on the efficiency here, how much you get. So maybe it's not really pure carbon dioxide going here, but it can also be having some of the carbon dioxide. With that, I hope this is useful, and see you next time.